right. Yeah, so I'm going to record this and we'll post it back up. Found out the secret to getting these videos up is to upload them onto YouTube first. So we should be fine. We should have video now for you guys just to go back, be able to go back and look at and rewatch as you're studying.
Yeah, that would really help, Brother Northrop.
Yeah, so this will be posted again for you guys. That way you guys can look at it and review it as you need. But I'm actually going to do something a little different this time. I need to be better about this, but let's start with a prayer. Does anybody that be willing to say a prayer real quick?
I'll do it.
All right, go ahead, Pierre.
All right. Our dear Heavenly Father, we thank you for the opportunity tonight to be able to study as a group and be able to learn and be able to get the information that we need that will help us with our upcoming exam. We ask you for the Holy Ghost to bless us and guide us for the things that we need to learn and retain, and also so that we could have like good questions to ask to Brother Northrop that it will be addressed. And this we leave in the name of Jesus Christ. Amen.
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 Awesome. Thank you.
You're welcome.
Right. So I'm also going to post this PowerPoint. This is another review that I've put together today based off of another instructor's review. And this one's really good. The other instructor that kind of started this, and I just added a few tweaks, built this right off the exam. So this is a good one. This one should help you guys a lot. So let me share the screen here. Perfect. Okay. Can you guys see it okay?
Yes.
Yes.
Awesome. All right, let me get here. Okay, so just with this exam, it's just the same format as the last two tests we've taken. This one's going to cover the mass wasting and the flooding. And Karen, you brought up a really great point that next week is kind of going to be busy and crazy for everybody, with the 4th. And so I haven't announced it yet, but I am going to extend the due date, the deadline for the test.
Yay!
So that way you guys can enjoy the 4th.
Oh man, I'm always I was worried about this.
Well, you don't need to be worried about it. You guys will have a little bit more time. It'll probably be, like Monday or Tuesday of the following week.
Thank you.
So that way you guys don't need to worry too much about it. Also just gives you a little more time to enjoy family and the important things. So with that, just a few notes. Again, this test is closed book, closed note, all that stuff. So without further ado, then let's just dive in unless there's some questions you guys have from the get-go.
No questions.
No questions.
All right. Well, let's dive through this. Okay. We'll start with mass wasting. So these are just a couple of different things you need to know. So of these for this section of the test, you need to know what are the different types of mass wasting, and then how do you recognize the following? So like creep, ancient debris flows, and slump rotational slides. And I'll give you a hint. If you see a question on here, like I'm asking you to study something, that means it's on the test.
Oh, okay.
So what are the causes of mass wasting? What is the likelihood of mass wasting reoccurring in like an area? What are some ways to stabilize the slope, and how do you reduce mass wasting in an urban area? So yeah, let's do that. So that's all from there. So what I want to do, we've just kind of gone through some of these questions, and I just want to take a second and let's talk about each of these questions. And maybe we can figure out the answers to get some of the answers together, and that should help a lot. So do you guys remember what are some of the different types of mass wasting that you studied?
Let me look at my notes.
You're fine. You guys can feel free to pull up your notes and look at those and different things.
Well, if I knew how to use my computer. Let me think. What mass wasting?
I'll give you a hint. There's 3
mud
on the slide.
flows?
Yeah, that's right. Mud flows.
Not Lahar.
A lahar is a type of mass wasting, but we'll leave that in under volcanic eruptions
Okay.
and stuff. But what a lahar
Debris.
is kind of, say that again?
The debris.
Yeah, the debris flow, which a lahar is a type of debris flow. You think of any others?
Earth flow.
Yeah, earth flow. Perfect. Thank you, Lorraine.
I
Any
can't.
others? All right, let's pull up something. Okay, we're gonna minimize this for a minute.
Yeah, I don't know how to make my computer small.
There
Look
we
at
go.
my
I
notes.
found it.
Yeah,
I found
that's
my
the wrong
notes
one.
on this. Slump are those part? Yeah, the
Yeah, slump is
Oh,
one.
creep,
oh.
clip
Creep, that's
retreat.
right.
Yes.
So here, this chart that I've got up, can you guys see the chart okay?
Yes.
So this is a couple of the major ones. So you've got a rotational landslide, which that's also a slump, right? And do you guys understand what it's doing? It's kind of curving as it falls.
Mm-hmm.
Yeah, it kind of rotates. Then you've got a translational landslide. And you remember what the the difference between the rotational and a translational landslide is?
I don't see the slump in that translation. I don't
So
see the
this,
slump.
in this one right here, the translational?
Yeah.
That's right. There's no slumping in it. It's simply sliding in a straight line. There's no curvature in it. Does that kind of make sense?
Yes.
Mm-hmm. So just think of it, translational is sliding across something, and rotational, it's actually got a degree, element of rotation to it. Then you've got a block slide, which is like a translational landslide in the sense that it's sliding in a straight line. There's no curvature to it, but it's like a big block is just sliding off. I don't know if that kind of makes sense. So just imagine a giant chunk of rock just sliding.
That makes sense.
Mm-hmm.
Is that usually sorry,
go ahead.
Brother Northrop. Is that usually caused by earthquake, the block slide?
It can be. It can also just be a plane of weakness. Let me show you a picture here of a block slide. Let's see. Images. Let's find a good one. So this is kind of like a block slide. It's hard to see in this image. I'm not seeing too many that are great, but it can be just like a plane of weakness right here. Like let's even say maybe a clay layer or water gets in there and then it freezes overnight. You remember the freeze thaw, how that can expand rocks and or expand cracks and make them break and slide down?
Yes.
So this could be, a block slide could be caused by that, water getting into some cracks and then freezing, which causes the ice to expand and it breaks a big chunk off and it slides down as a big block slide. Can be any number of things. But yeah, an earthquake is definitely one thing that can do it. Does that kind of make sense, Pierre?
Yes, thank you.
Perfect. Then you've got a topple, which is just basically it falls, like a whole section just kind of topples over. And then debris flow. You guys remember can you guys tell me about a debris flow?
Oh, it has a bunch of rocks and mud, bigger boulders. Everything comes with the debris.
Yeah, that's right. And then you've got a debris avalanche, which is similar. It's just a little thicker, if that makes sense. Less water involved. And then you've got an earth flow. You guys remember the difference between an earth flow and a debris flow?
When I was looking at the last slide, it looks like the whole earth was moving instead of just watery or rocks and bricks. It seemed like, everything kind of was moving, the earth. It seemed closer to the ground and not like coming down a slope almost.
Yeah, I'll show you a video so you guys can kind of see a debris flow first. Let's watch the Colorado one. So this is a debris flow that happened in Colorado in 2003. And you can see there's big boulders coming down, big rocks. It's like a river filled with mud and giant boulders and rocks. You see that right there? So this is kind of a debris flow. Now let's look at an earth flow.
I remember the last picture you showed, it looked more grassy.
Yeah, let's look at this one. This will show you a big earth flow.
Oh, it moves slower.
It's slow, a little slower. They can be fast, but you'll notice it's mostly just soil. It's not picking up trees or anything. You know, it's just, which it would if there were trees in the way, but it's just more muddy
Okay.
and not so liquid. And you can see it's just this big thing coming down the side of the mountain. So think of a debris flow as a whole mixture of stuff.
Debris is a mixture of stuff.
Mm-hmm. Where an earth flow is not so much, and it's kind of flowing down, which would be a little different. You know, I guess they're both flowing, but.
Mm-hmm.
And then you've got a mud flow. You think of a difference between a mud flow and an earth flow?
Mud is more liquidy.
Yeah, mud flow. I'll show you a video of that. For me, I'm a visual learner in a lot of ways, and I feel like seeing the videos helps.
Same here.
Good. I don't know why we're getting an ad. Let's get through this ad. There we go. So that's a mud flow. You see how it's much more watery?
Uh-huh.
Mm-hmm.
Faster.
Yeah. So this is a mud flow, and then I'll show you the aftermath of a mud flow. So it looks watery there, but then afterwards, you can see everything is just caked in mud.
Mm.
And these can be, you know, really devastating. All of these are really devastating. All right, let's go back to your types. And then I don't think there was any questions on the test about lateral spread. Let's see if there's any others. This is I got this up here. I've got to move this down. Zoom has a toolbar right at the top, right where all my tabs are. Okay. That's not the one I want, is it? Here we go. This one's got a little more for you guys too. So then we also have here creep. Do you guys remember what creep is?
I'm trying to look at the picture and figure it out. What was the note about the creep?
Anybody got any ideas? First, maybe this will help. Is creep fast moving or slow?
Slow.
It looks like it's slow.
Yeah, it's really slow. Let's go down here to debris flow, mud flow. There's another good picture of a mud flow. All right. Creep. So this is creep. Remember, it's just where the ground is slowly moving down the slope. Often this can be caused by freeze-thaw. So it freezes, like this figure here, you see the little arrows. It freezes and it moves, expands and kind of moves forward, thaws and goes down. Freezes again, expands and moves forward, and thaws and moves down. Or it can be drying or cooling, anything like that, but it just is slowly moving down the side of a mountain. So how do you think you can recognize creep? And I turned it here on this one. You should be able to see. Try not to read it, but how do you think you could recognize where creep is?
Oh, I remember this because of the tree. It looks
trees.
like a
That's right. So when you look at the trees or fences or power poles, they'll be kind of scattywampus, or you know, they won't be straight up and down, and that's indicative of creep. Awesome. Let's see. I don't think I want to go through the rest of these. You guys also, another really great place to go to review for the tests are the videos where I talked about floods and landslides that were posted, the Thursday reviews. I think those are posted, right?
I think so, yeah.
Yeah, so those will be really good because they can talk more in depth about each of these. For now, I'm just kind of focusing on the PowerPoint and the tests, so I won't dive too much into those things. So here's the next question. So we talked about what are the types of mass wasting, so try and remember those. Now, how do you recognize the following? So we just talked about creep, how we recognize creep. But do you guys remember, or just think about a debris flow? How would you recognize an ancient debris flow?
Ancient. It wouldn't be. Would it be any different than a debris flow? Seem like the boulders may be bigger. I don't know. When you say ancient, would it be? I don't know. Would it be like old stuff? I mean,
You're
I'm
close. You're doing real
thinking
good.
about pyramids. You say
Yeah,
ancient,
for
I'm thinking about pyramids. And
Yeah, let's say
yeah,
I'm just saying something like that happened a long time ago in the past and has since like been grown over. You know, plants and stuff have grown over.
yeah. It's
oh,
like
like,
for me.
go
Oh,
ahead,
go ahead,
Pierre.
Karen.
Sorry.
Oh,
No, no,
okay.
you go.
It's like for me when you say ancient debris flow, it's like the boulders or like the big
Hmm.
ones are like where the community used to be, and then it's just kind of what you were saying, Mother Northup. It's just uh like grass grow over it or something.
Yeah, exactly. So an ancient debris flow that's not in the rock record, you know, like let's say you're driving down the mountains or in a road cut, and you see all this muddy, kind of like all just like in the dirt. You see giant boulders, small boulders, old logs, just a whole mixture. Because remember, a debris flow is a whole bunch of debris.
Mm-hmm.
You just see a whole bunch of debris with grass and moss and trees growing over it. You know there was probably an ancient debris flow right there. Does that kind of make sense?
Yep.
And the same kind of goes true for in the rock record. When you look in the rock record, you can look at a debris flow and we can recognize them because look at this image here. You can see big boulders and little tiny rocks and all sorts of different things, you know, kind of mixed in there. And this is kind of what a debris flow is. So if you think about it, not in the rocks, but let's say this is, you know, not quite this old. You can say, oh, if this were just kind of more muddy dirt and there was grass over the top here, that's what it would look like. You'd see big rocks and little rocks and trees and roots and all sorts of stuff. Does that kind of make sense?
So
Yep.
basically, you're saying for ancient debris flow, you will see that the grass is growing over the rocks.
It's gonna look like a big hodgepodge of big rocks, little rocks, mud, trees, all sorts of stuff. The other thing you can look for is, let's see, uh, let's see that this should have some good images too for you guys, like that.
Ah,
Does that kind of make sense looking at that?
Yeah.
yeah.
So you can see all the big rocks, and I'm sure there's wood in there. It's a little harder to see at this angle, but all that stuff right in there. The other thing you should see, let's see if we can find a good image of it. Right here is one. Look at, this is where the debris flow was. And you see how it's all kind of lumpy and weird looking, the ground, the topography? It will have that really weird lumpy topography. So kind of it's what you'd be looking for is that lumpy topography and all the big mixture of rocks and dirt and all that stuff that's under the vegetation.
Okay.
Awesome. That's a very interesting.
And then how do you recognize a slump or a rotational landslide? Do you guys remember?
Okay, we know the rotational is curved.
That's right. There's an element of turning.
So slump is isn't that like a straight through?
No, a slump is the same as a
Oh.
rotational landslide.
Oh, okay.
Let me pull up an image. Slump. I want to find you. We'll look at this one because this is a good one. So what do you see that kind of makes you think like looks a little different?
Looks like the road is two pieces.
Yeah, the road is. You see how it's kind of a bowl, like right here?
Oh, mm-hmm.
And you can see there's kind of this characteristic like stair stepping.
Yes.
Yeah.
That's kind of what you're looking for in a slump. Let's go up here. You can see this image here. Look, you can see a little bowl right here.
Uh-huh.
Oh, uh-huh.
And then it's kind of gone down. And this is a really small one, so you don't see as much stair stepping. But you can kind of see that there. This is another one right here where you can see a little slump. And just you're kind of looking for that bowl shape.
Did we lose him?
Oh, I think I see that here in our area.
Oh dear.
Especially the ones that it's closer to the cliff.
I'm sure you do. That's really common to see these along cliff sides. Here's another slump right here. And look, you guys can see the stair stepping right here. All the way up. And there's the bowl shape.
Oh.
So that's kind of what you're looking for in a slump.
Oh, shit. Okay.
All right. So what are some of the causes of mass wasting?
Melting snow.
Yeah. How would that cause mass wasting? You're right.
Well, it just creates a lot of water, and the soil cannot absorb it.
Yeah.
So hence the soil will just go down.
Yeah. So think of it this way: as the water goes in the soil, I'm going to. As the water goes in the soil, imagine all these grains of sand or dirt packed closely together. And then you get the water in there and it kind of expands everything. And all of a sudden those grains aren't locking onto each other anymore. And they're kind of floating, if you will. There's a little bit of water in between each one. And now it's really easy for them to flow. So as that snow melts, more water is introduced to the soil and those grains are pushed a little further and further apart as that water moves in and creates planes of weakness. Does that make sense to everybody?
Yep.
Yes.
Perfect. What's another thing that can cause mass wasting?
Heavy rain.
Yeah, heavy rain. And for the same reason, that water oversaturates the soil becomes weak because it's not as cohesive and it can break. What's some other ones?
I'm gonna say humans when they take away trees and stuff.
Yeah, great job. That's a great one. Yeah, so when we move in and remove vegetation. Why is that? Why could that contribute to causing mass wasting?
Because nothing is gonna hold on to stop the flow. I think that's what the trees does.
That's right.
Stopping any of the going down, and if it doesn't have anything to cling on to, it'll just go down and does its thing.
That's right. So the roots of the grasses and bushes and trees act kind of like an anchor for the soils. And so the soils will kind of cling onto those and that will hold everything together and in a cohesive ball. But if we take those out, all of a sudden, think of it, as all the internal structures removed. A good example is when you think of, when in construction, when guys are working in cement, a lot of that times you see them putting the rebar in and that adds all the strength. Well, it's the same thing with the tree roots. They're like the rebar that strengthen the soil. Great. What's another cause of mass wasting? There's quite a few, and I want to get as many as we can. What is something you always have to have for mass wasting? And it's everywhere on Earth.
Dirt.
Well, yeah, you do have to have dirt. But think more broadly. It's gravity. You have to have gravity, right?
Yes.
So what would help gravity cause mass wasting?
It'll just straight go down.
Slope?
Yeah, slope. If you have too great a slope, you can cause mass wasting. Right? You guys remember how there's kind of that 2-to-1 ratio is kind of that magic number for the slope, and anything greater than that is at risk for mass wasting?
It was 34, right?
Yeah, 34 degrees.
Okay.
Great.
Okay. Okay, so far I have melting snow, heavy rain,
Mm-hmm.
trees, and
Yeah,
slope.
removing the slope. Okay. Can you think of any others?
Um, come on, Pierre. Okay.
Let's go to PowerPoints.
Oh, what is that? Buttress. What is that?
Okay, let's see here. Okay, why do you think there would be mass wasting here?
Because, oh gosh, this happens in one of our clips.
Uh-huh.
I think it's because of there's nothing to hold on to, plus the waves, I think. It's the
That's
water.
right. Right. So the
Yeah.
waves are going to come in and they can erode out the base, right?
Yes.
And without that support underneath, all of a sudden, your cliff is going to be way too much and cause it to collapse. Great.
Yeah. We have this in one of our cities, Pacifica,
Uh-huh.
and they had they had apartments built on the cliff, and now they have to get rid of those apartments.
Right. Because
Yeah.
of this. Uh-huh. Exactly. Very good. Let's see if we can find any others. So we've got freeze thaw. Remember, creep can be caused by just the freezing and thawing of the soils. And let's see. I think you guys have gotten most of them. The last one I will say is volcanoes and earthquakes. Remember?
See, I was thinking about that one.
Yeah. Just a sec. I gotta grab my charger.
Earthquake. Freeze thaw.
Sorry, my computer was running low on battery.
Oh, no problem.
No worries.
So yeah, so you have volcanoes and earthquakes that can cause it as well. Awesome. Okay, now what are some other things that man does that can cause mass wasting?
I want to say damming. When they put dams up, does that cause it?
So why do you think that would cause it?
Because the water can get trapped and.
Yeah, that's definitely one thing that they could do it. I'm trying to find. I remember there was a slide that talked about this, but I can't remember where it was. Here we go. This guy. So you've got that. We've got other things. So this slide right here. This is the first PowerPoint from the landslides week. And if you go down a ways, so it starts off landslides, blah, blah, blah. They talk about learning objectives. What's a landslide? Angle of repose. There's what causes landslides. So starting here on slide 15, you talk about water, earthquakes, volcanoes, and slope. You can also get flooding, which can be by the damming. Landslides can also cause dams. But then let's go down here. Landslides, volcanoes, human activities. Here's some things that we can do that sometimes cause landslides. So one is grading or excavation that removes material from the base. So just like with waves, sometimes we, like when we're building a road, say like right here, we'll cut off a little bit of the base to make room for the road, and that'll weaken the whole slope and can cause a landslide. Sometimes we do the opposite and put a bunch of material on the top of the slope rather than cut off the base. We put a bunch of material up high to make way for a road, and that can overburden the slope and cause a landslide. Sometimes we also do things where we change how water flows through areas, and that can cause landslides because it can saturate certain areas with more water than it's used to. Other things that can happen, this happens in cities and stuff. Let's say you have a sewer main break, and all of a sudden all this water is introduced into this hill in this town. That hill could have a landslide happen. So there's that. Other things you can do is cause fires. When fires can do that, and that's because they burn up the vegetation, things like that. So these are kind of the main causes of it that cause landslides. There's one other, and that can be weak materials. So sometimes you'll have a layer of rock or or clay underneath that's really, really weak, and then just something happens and it all of a sudden breaks or slides. Remember talking about the clay and how clay can cause landslides, layers of clay? So those are a couple of the things that can cause landslides. All right, or mass wasting. So once you've had a mass wasting event, what is the likelihood that it could reoccur?
It can reoccur.
Yeah,
it's very likely.
Yeah, it's very likely, right? You already know you have conditions there that are prime for a mass wasting event. Sometimes it's not super common, or sometimes, like in some instances, it wouldn't reoccur. But that's only instances where, let's say, you remove the slope and everything and all like the main factors. But often that is only after we as humans have gone in and done some mitigation to stabilize the slopes. So what are some ways that we can stabilize slopes? Do you guys remember?
What I remember is the vegetation. I see this a lot in Central America and in my country too, in Philippines.
Yeah, where we'll go in and we'll plant stuff. And it really helps. Yeah, very good. Can you think of any other ones, you guys?
Building those big boulders.
That's right. Let's go. Why don't we just go to this slide here, and we can show a couple of them. So we've got, where's the boulders one you're talking about? Well, anyway, yeah, you put the big drape of boulders over top, which acts as like a something to hold it down. Very good. We also have terracing. Remember, where you can put the ground in terraces, like right here. And rock walls. Here you go. Here's the boulders and rocks where you kind of put a blanket over. The other thing we can do is we can also, this slide right here is really good. This kind of goes over the different things we can do. We can grade it where we actually decrease the slope. Like right here. So you got this cliff, and then when we come through, we degrade it down and put vegetation in. So these are just some things that we can do to really help mitigate against future mass wasting. All right. And we'll so we've kind of talked about this, but what are some ways we can reduce mass wasting in urban areas?
It's not the same.
There's some extra things you can do.
Like put some, like, what do you call this? Like put some cement around the place that it will have that potential mass wasting.
Yeah, you can coat it in cement.
Yeah.
You can make sure there's proper drainage of water. Make sure that your roads just aren't pooling water down the gutters, that the water is going somewhere rather than into the dirt. Just a lot of things like that. Just make sure there's adequate water removal. Make sure you've got, you can do the roads, like you were talking, put the layer of concrete over the top. Sometimes they also do giant wire nets. Great. So those are a lot of the things you can do. So let's keep going then. So then the next slide, these are just some details from the case studies that you should know. So know what the most expensive mass wasting event in the US was, which, do you guys remember?
No.
Okay, go look it up. Go through the PowerPoint.
All right, we'll look it up.
And then which landslides were repeat events where there had been a landslide there previously? So know that. And then what follows is I have each landslide, and just something to know about it. So the Oso, Washington, know the history of the landslide. La Conchita, know the loss of lives, mitigation efforts, the land composition, coastal California, stuff like that. Bryant, know how the dam moisture in the rock and the tilted layers contributed. Lituya Bay, what triggered it, and know what the size of the tsunami was. Remember, it was a huge tsunami. Anybody remember it by chance?
Let me think.
I can't even remember some of them. I have
Yeah,
to look at my
so go
notes.
back through and review them. Yungay, Peru, know what triggered the event, know the death toll. Huiyan, China, same thing. And then in Frank, Alberta, know what triggered the event. Now, if you guys remember, there's 2 case studies that we provided you guys. Actually, I think it's just one. And that's that Frank, Alberta. So go back. We have a presentation that we put together that you guys can study from. It has all the information you need as well. So that's just, you can access this where you access the information for the other case studies as well.
Okay.
Okay, we'll move on there. Flooding. Okay. Flood insurance. Understand when it can be purchased. You guys remember that?
I was trying to look over that today, and I couldn't really find the answer to when it can be purchased.
It's kind of hard, right? Remember, it has to do with 100-year floods and floodplains. So basically, if you live in a 100-year floodplain, I don't think you can get flood insurance.
Yeah, so I couldn't find that answer today because that was the one I was looking for.
Yeah.
On your
no, what causes a stream to meander? Do you guys remember?
insurance.
So, or a river. Remember meandering rivers?
That's the one that that changes, right?
Yeah.
The concept of the river because of let me see. Where is that?
Oh, the S one. The one
Yep.
with the snake.
The big curvy snake-looking one.
Okay.
I'll give you a hint. Look at this picture, and what's the topography like?
Doesn't look like it's inhabited.
What's the topography, though, like the elevation?
It's low?
Yeah, it's relatively flat, right?
Oh.
Not a lot of mountains and other things. So meandering rivers are caused by, first off, a little bit slower river. These rivers aren't like roaring rapids, right? So a little bit slower river, low topography, and just one big channel. So it kind of does that. And what's going on is it's got this low topography, but then there's one other factor that's involved. And this is kind of the important one. And we're going to go to the PowerPoint for this. We've got, I think the second one's, there we go. Okay, right. We'll look at this page right here. Do you remember how on the cut bank, on that outside edge, it's eroding?
Mm-hmm.
And then it's depositing the sediment on the interior in the sandbars? So if you look at it here, you've got your sand point bar right here, and you have your cut bank. The water's coming through, and as it comes out through this side, it erodes this cut bank. And at the same time, it's depositing sand right here in the point bar. So what's happening is the river, this bend is getting worse and worse as time goes, and it's depositing more and more sand in here to fill it in. So it gets even more curvy. Does that make sense?
Yes.
Yes.
So it's typically lower topography. They're not as fast. They still move pretty good, but they're not as fast as, like, you know, these mountain streams. But the main thing is this erosion on the cut bank and deposition right here in the point bar.
Brother Northrop, I have a
Uh-huh.
question.
Yeah.
So how does it make it into like a snake-like figure without
Great. Mm-hmm.
yeah,
Well,
like how does it make it into that point, not having like just one straight cut through point of a river?
yeah, sure. Let's go back to this picture here. How does it get this shape kind of deal, right?
Yeah, yeah, that's my question.
So what happens is it's coming through and it erodes here. And this can just be caused, it can be following just the natural geology and natural lows. And basically what's going to happen is your stream's is going to have a slight curve to it, and it's going to start eroding into that curve right here. And it's going to accentuate it, and make it worse and worse and worse. And it's going to create a curve over here as well, because this is curving. Let's say this was relatively straight at one time, and there's a little bit of a bend here and bend here, and it just starts accentuating these little minute bends that were there and makes them more and more curvy over time. Does that kind of make sense?
Yeah. So is it potentially like that example? It's potentially that water will eventually like cover that little strip in there, and it'll just go straight through
Like
time.
right here?
No, the other one, the one that you were pointing before.
Like right
Yeah.
here.
Yeah, that
Yeah.
one.
So like what will eventually happen, and you can actually see it happening right here,
Yeah, right there.
is eventually the river is going to be like, you know what? It's easier just to go straight. And what it'll do is it'll go straight right through there, and it'll cut and stop flowing right here. And it will happen is this will actually become what's called an oxbow lake, a little tiny lake. And if we look at this picture here, you can see that. Here's the river, and you can see, look, here is one of those
Ah,
meanders.
Mm.
But
ah.
it cut through because it was easier. So now you have a little lake. Here's another one right here.
Yeah.
So you can see those. Mm-hmm.
And
Mhm.
that's usually caused by the very heavy flooding to
Not
be able to do
necessarily.
that.
No, what will happen is this. We'll look at this one right here because you see it happening right here as well. You can
Mhm.
see it's eroding out right here and depositing right here. Then it comes around and starts this way and it's curving. And remember, it always erodes on that outside edge, right? Well, it's eroding over into this outside edge. So these two parts right here, these two cut banks are eroding into each other
Yeah.
and will eventually completely remove this strip of land, and the water will just go through.
That's so interesting.
Uh-huh. It's pretty wild, isn't it? So does that kind of answer your question there?
Yeah, it does. It does. Now I kind of get the concept of the why.
Perfect. Good. I'm glad. So that's what causes our rivers or our streams to meander. Also, do you guys remember how a 100-year flood is determined? Remember, it's a statistic.
The
Is that
largest,
the one?
the
Is
largest
that the one?
flood
Yeah,
in
we
100.
got it.
Yeah, nailed it, Karen. It's in a 100-year period, it's the largest flood that happened. And then what we do is we look back and say, okay, well, this is the size of the largest flood in the last 100 years. But we'll now call this a 100-year flood. But now there's a statistic to it. And what is that statistic? Do you remember?
Is it 1%?
Yeah, that's right.
1%.
There's a 1% chance of a flood that size happening that year, every year for, because it's a 100 years. So it's just a statistic. That's the important thing to remember. So since it's just a statistic, that means that you could, in theory, and I've seen it happen, have multiple 100-year floods in 1 year.
Mm-hmm.
You can have multiple 100. You could have something like this where it's been 50 years, or it's been 90 years since the last 100-year flood. And then in 3 years, you get 4 100-year floods. Because, again, it's just a statistic. It's not based on anything actually really scientific. It's just simply looking back over the last 100 years. Does that make sense to everybody?
Yes.
Yes.
Great. Okay, what are some things we can do to control the risk of flooding?
Is this the one they talking about levees?
Yeah, That's right. So what is a levee? Do you remember?
Of course I do.
Is that the one that you have to build some sort of a wall or something?
Yeah, it's kind of like a little wall that contains
Yeah.
the river, right? Let's go up here. And also, here, we'll look at,
Let me see my notes.
here's a really good image of levees. You see this wall right here?
Mm-hmm.
That's a levee. Kind of just this raised. This right here, do you see a wall right here that's man-made?
Mm-hmm.
Uh-huh.
Yeah, there's a levee there. Now, we can also get natural levees. So that they just form in nature, and this is normal. Levees form naturally on almost all rivers. Let me get this up, and I talk about it more in over the last weeks. But you can see here, you see this little berm.
Yeah.
Mm-hmm.
This is just nature where the levee is, and basically that's just formed as when this river goes into flood stage and starts flooding and goes over the levee. What happens is a lot of the sand and dirt and mud gets deposited right here and actually builds the levee up. So this is just where most of the deposition happens of all the material carried in the water. So we'll leave that at that about levees, but what are some other things we can do to control the risk of flooding?
Dams.
Dams, yeah, that's right. We can build dams and control the amount of water going down the river at certain times of the year so that we can mitigate against flooding. But what is one of the big risks about dams?
And when you get like a heavy rain and it just fills it up, and then you have no choice but to actually drain it, then
Yeah,
hence causes more flooding.
yeah. Or even in some cases where they don't drain it and it just overflows the dam, huh?
Yeah.
Mm-hmm.
Now, what's some of the risks with levees?
They break.
That's right. You can have a levee break. I'm going to show you a video here. Maybe. This levee breaking.
Hi, Annie.
All right, let's skip this. All right. Now watch this right here. Do you see that right there where the levee all of a sudden breaks?
Uh-huh.
And now look how much water is coming in.
Oh, wow.
You can see massive amounts of water are flooding into that area now.
Mm.
Let's go back here and let's look at images. And this will really show a really good image right here. Look how much water is flooding through where this levee broke.
Mm-hmm.
So levees can be really good, but if they fail, it can be catastrophic. What are some other things, though, that we can do to mitigate against flooding? So we've got levees.
Mm-hmm. Down.
You guys remember this one? Channel modification.
Oh, yeah.
So this can be just simple things like deepening the channel or making it wider. Just kind of making the bathtub bigger so it can hold more water, if that makes sense.
That's a great analogy to put. I'll
Mhm.
remember that.
Yeah, there. Then there's rip wrap, which is where you put these big boulders here on a levee. This is to kind of strengthen a levee. And these big boulders, the water's not going to move, so it kind of prevents erosion from happening on the levees and stuff to break through. Okay, so I think we've gotten most of those. Understand the link between flood discharge and a drainage basin. Do you guys remember what a drainage basin is?
Isn't that the one that where all the river would come to a point and then it just goes to the ocean. Is that what it is?
Yeah, basically, let's look at this right here.
Mississippi, right?
Yeah, so like the Mississippi drainage basin. So you've got your main river here, and the drainage basin is includes all the other little rivers that feed into that main river. So basically, everything in this area is going to drain into this river. So now back to our question, the link between flood discharge and drainage basin. So what it's asking is, how is the amount of water, like the severity of a flood, linked to the drainage basin? So what can you guys come up with an idea of looking at this? I'm going to find a better image for you that will hopefully help.
So it's like a bottleneck. So if there's a lot of water coming from all over all of the rivers merging into one drainage, it will just cause a flood on that specific area because that's where it drains.
Very good. Very good. That's right. So if you're getting a lot of water all through, this right here is the Mississippi drainage basin. If you're getting a lot of water, let's say draining, or let's say you get a record snowfall up in Montana, Wyoming, and parts of Colorado, well, all of a sudden you've got all that melting in the spring. What's all this super extra water? Where's it all going to end up? Right here in the Mississippi. And it can cause flooding out here in the Mississippi because you've had so much water out in the drainage basin. Does that kind of make sense?
Yep.
Good.
So how do you word that?
How would I word that? Like,
yeah, so if they ask the question, what's the links between flood discharge and drainage basin? You just say it all drains into one area. How do you word that?
So the good thing for you guys is the test is multiple choice.
Oh.
But I would say something probably along the lines of high discharge within, or large amounts of rainfall within the drainage basin will increase the discharge of the flooding discharge.
Okay.
Okay.
Great question.
Sometimes the questions are very tricky.
Yes, you need to read them very carefully. Okay, river formation. No, fast-moving versus slow-moving rivers. So remember, we've got 3 types that were in the presentation. You've got meandering, which we just talked about. What else did you have? I'll give you a hint. Look at the second bullet point.
Braiding.
Yeah, you got your braided rivers. And there was one more. It was those mountain rivers, right? Like the high elevation rivers. So if we were to rank these in speed, we would say a meandering river is slower than a braided river, which is slower than the mountain rivers. Now, why is that? Why do you think why do you think the mountain river is so fast?
Because
gravity.
It's gravity.
That's right. Mountain rivers, right? They're straight and they're going down. Look at the gradient just on this river. Come on, why are you not showing me the image? Look at the gradient just on this river. And you can see this thing's not going to meander. It's just going to go straight. You know, it's all the erosion is happening as it's cutting down. So that's the fastest. And then you've got your braided rivers. Look at this one. This one's gorgeous.
Oh, that is beautiful.
Oh, wow.
Look at that braiding. Isn't that crazy? Anyway, let's look at this one though. You can see here, they're a little higher. It's still fairly flat, but these ones are moving faster. The braiding happens because it's moving faster and it has a lot of sediment in it. Okay, so that's why this one's faster. There's a little higher elevation typically. Like there's a little more gradient, if you will, than you would have on a meandering river. Okay, and then they're moving faster, carrying more sediment, so it peaks them into smaller streams, which can actually help it increase speed, like moving into smaller streams. And then obviously I think we kind of understand meandering rivers. It's a big body of water. It's pretty flat. That's why it's the slowest. And that also kind of compares the braided rivers with meandering rivers. I also recommend for you guys for this test, go back to the video where the review from last week that's posted where I talked about braided rivers and meandering rivers. And that should really answer the differences between them two. Know some of the hazards between them too. So, you know, these braided rivers, and I don't talk about it too much, they have right here, this is kind of, this whole area right here is liable to flooding. This whole stream bed right here. Does that kind of make sense? So this is the floodplain for those, which it can extend out a little further, but this is the kind of the main floodplain. This where you see all these point bars and stuff. Does that make sense? These sandbars.
Yes.
So now let's look at a meandering river floodplain. Oops, I totally spelled that wrong. Okay. Now, look at this river. Look how flat it is. When that thing floods, this whole valley is going to be filled with water because it's so flat and there's so much water. We can look in here. You can see this illustration. This whole area right here is the floodplain. So it has a really wide floodplain on your meandering rivers. Does that make sense?
Yes.
Yes.
So that's that. Go also back through the presentations and just kind of go through, make sure you understand some of the hazards with them. And then alluvial fans. Do you guys remember alluvial fans?
Yeah, that's the one that looked like a fan on a mountain.
That's right. Pull up a great image here. Well, even, that's too small. I was going to give you that one because it's pretty, because it's, so you got this big fan here. Now, how did this form? Do you guys remember?
Volcanoes?
No?
I don't know.
I'm not sure. I don't
Okay,
think.
let's look first. This is in flooding, so it's got to be water related, right? So you've got this high gradient right here, mountain river that comes down through here. When you get a lot of rain up in these mountains, you can actually get debris flows that come barreling down this river and boom, come out here and create your fan. These are debris flow, these are flows, and that like flows of debris coming down the river of rocks and mud and all that stuff from high when there's a lot of rain and kind of like flooding, if you will.
Oh, born from rain and flooding.
Yep. Okay. Any other questions on that?
Nope.
No.
All right. Well, we got more to talk about. How does urban development affect flooding? Do you guys remember?
Because we remove all the vegetation and trees and
Okay, and what do we replace it with?
Cement.
Cement. And water can't get through cement to get into the ground.
Yes.
So essentially, when we remove all those trees and plants, like Karen was saying, and replace it with cement, we put this impermeable barrier and the water will just sit on top of it. And if we don't have proper drainage, it'll actually flood. All right. And we talked about water flow in streams, in the stream in areas of erosion. But I want to show you guys a certain slide. But I've got to remember which PowerPoint it's in. It's not this one, because that's meandering rivers. Where are you? Okay, it's got to be this one then. Nah, here we are. Okay. This one right here. So we've got right here where the most water is moving, and the fastest movement in the water is right here in the center. And then go down here. Our erosion is occurring on the outside edges of our bend, and
Mhm.
deposition is occurring on the inside, right? So erosion's happening out on the outside called the cut bank. Remember that, cut bank. And
Mhm.
deposition is happening on the inside at the, you guys remember what it's called?
Inside.
I put a help up for you.
The sand point bar.
Yeah, at the point bar. This is called the point bar. And
Point
this is an easy way to remember it. The point is on the bar. The point is on the sandbar right here. So it's a sand point bar. So remember, that's where the deposition is happening. Okay. So
Awesome.
that's all we'll talk about with water flow and stream and areas of erosion. Any questions?
Okay, I got a little confused there. Erosion is on the cut bank,
Mm-hmm.
but the inside you said is the point bar.
Yes. So the cut bank is this outside of the curve.
Okay.
And that's the cut bank where the erosion's happening.
Mm-hmm.
Think about it, as the water flows, water's not going to hug. It's not going to hug as much this interior as it is going to kind of cut along on this outside. It's going to want to kind of push against this side. Think about it when you're, you know, those rides at like the carnivals and stuff when they have the swing and it spins around and you're being pulled to the outside, right? Well, that's exactly what that water is doing. It's getting pulled to the outside here and it's eroding this wall. So this is the cut bank where the erosion happens. The inside is getting deposition. The water is actually moving slower right here. And since the water is moving slower, all the sand and silt and clay that's in the water is able to drop out of suspension and deposit it these nice sandbars or point bars. So cut bank is where the erosion is happening on the outside. Point bar is where the deposition is happening on the inside.
Okay, got it. Thanks.
Yeah, of course. Okay. Unit of measure used for stream discharge. We'll just pull that up on the PowerPoint. And right here. So it is discharge. Here you go. The volume of water that flows by an established point, let's see, right there, cubic feet per second.
Oh, cubic feet per second.
You'll just have to memorize that.
Mm-hmm.
And know that cubic feet, to get a discharge, know this little formula right here, is area times velocity. Okay?
Yep.
And if you want to break it down further, area is the depth times the width.
Now that's a little too much to remember.
Anyway, just remember it's cubic feet per second.
Yeah, and area time velocity. Got it.
Mm-hmm. Okay, got that. Know how to tell the topographic floodplain of a river. Now I'm going to show you a picture on this one. This one's easier to see in an image. And that's the other one. Here we go. Now, this is looking here. You've got two types of floodplains. You've got your hydrologic floodplain and your topographic floodplain. Your hydrologic floodplain, if you remember from last week, is just the level that the water gets to when it's like spring runoff and it's high, the river's high. Okay? The topographic floodplain is kind of the top the river reaches when it's flooding. So this section right here, this area for a meandering river is defined by a significant rise in topography beyond the extent of the meanders. Does that kind of make sense?
Yes.
Yes.
So that's kind of what you're looking for. It's that little hill where the topography gets higher than the meanders kind of in the floodplain. Okay?
Mm-hmm.
So right here, looking at it, here's your river, your levied floodplain, which is basically this hydrologic floodplain, right? This is where your levees are. So your river can expand all the way out to here. Then you've got these bluffs that are over here, the bluffs are your topographic floodplain. Does that make sense?
Yes.
Yes.
Great. Okay. Depth of flash flood waters that will move a car. You know what? I don't even know that one. Let's see. Let's find that out because I'm curious. Okay, rip. Okay. Flash floods are coming deserts. We'll just search it. How deep? Uh,
1 feet? 1 foot?
yeah, 1 foot of water.
Wow.
So that kind of puts it in perspective for you.
Yeah.
I knew it was small. So yeah. Because think about it, right? All you got to do is just get the car to float just a little bit so that the current can push it downstream.
Yeah.
Very good. Okay, now this, I'm not going to go over this much. This is just for the case studies. These are the things you should go over to know for each case study. So this is Mississippi floods, Johnstown flood, Santa Clara, Big Thompson, Danube, California, China, and then Ice Age Lake Missoula, which is one we provide for you. So go through the presentations and go through the Missoula one, which is that presentation is just where you find all the other case study information. And make sure you know these things, okay?
Okay.
Awesome.
All right, any other questions?
Nope.
One question.
You betcha.
What are those things we do? Those labs. Any questions coming from the labs?
I would still study them because there are some good things from the labs. So for example, oh, I just thought of one and it's just left me. Oh, what was it? There was something in the guided lab that I thought was really good that you guys should know. I would go back through your guided labs, just make sure you're understanding what each thing is talking about.
Okay.
You know, if you kind of follow this study guide, know these things, go through the labs, and then the other one that I posted, the PDF one, you'll be fine.
Okay.
And then again, spend plenty of time on the case studies, know these things. I'll post that document next week. I don't want to post it now since people are still working on their case studies until 11 tonight. So, but that document is the one with all the answers to the various questions that they were asked to have.
Oh, cool. Thank you.
Okay. Any other questions or?
No,
No.
no questions. Thank you for providing this review, Brother Northrop. Really
My
helps.
pleasure. My pleasure. Well, with that, good luck. Remember to take time, study, say a prayer, read a scripture before you do it. Just do anything to, relax yourself, stay calm. I'm going to extend the exam date, so that'll give you a little more time to study as well. So, if
Thank
you
you.
guys have any questions before the exam, just shoot me an email and I'll be more than happy to answer them.
Will do. Thank you.
And
All
I
right.
noticed you said a little extra credit, 5
Mhm.
points, and just put it on that. Was it this week only?
Yeah, it's just this week, so you still got time.
Yeah.
Yeah, and just put it on the comments, either on the YouTube video comments or the announcement. If you put
Okay.
on the comment on the announcement, it's a little easier for me, and
Okay.
it's easier for your peers to see. But yeah.
Oh, Brother Northrop, before I leave, you know the final disaster paper that we're
Yes.
supposed to do, is that supposed to be a presentation or a paper?
Oh, that's a good question.
You'll want to do it as a paper. So
Okay.
I'm going to let me pull this up.
Good question.
Yeah, because I wasn't sure if I was going to make a presentation or a paper out of it.
Okay, here we go. We want a paper, but I'm going to give you a hint to show you something that'll make your life a lot easier. Share here. Sure. Okay. So you guys can see my screen now.
Yep.
Mm-hmm.
Okay. On this is the description of the final paper. And if you go down to bullet point number 8, you see this where it has these bullet points: location of the disaster, type of disaster, beginning dates, these different things. Copy and paste these bullets and then fill it in.
Oh, okay.
Fill it
Oh
in.
my, really?
Yep. Mhm. This will make my job a lot easier, and it'll make your lives a lot easier. Now, I still expect, for example, right here, like where it says total economic loss in dollars due to property damage, lost business, things like that, if available. If it's there, I want a paragraph, a full, well-written paragraph. Mitigation, I want a full, well-written paragraph. And then a description of the disaster and a short statement describing the cause of the disaster. Full paragraph, well-written. Okay?
Okay. And these are part of the disaster thing that we do every week.
Yeah, you can pull those. Make
Okay.
sure to read the project description, because in
Yes.
the project description, it mentions you need 2 of each type of disaster.
Yes.
Yep. Cool. Great
All right.
question.
Thank you. Thank you for clearing that up.
Yeah. All right. Well, I will let you guys go. I'm going to stop recording right now.